Hello guys, this is Rotational of Rigid Body, Part 2. Force is required to initiate rotation of an object. This ability of force is known as torque. The ratchet is used by applying some force at some distance r from the lug which acting as the axis of rotation. The force acting at angle theta to the ratchet and generate enough torque to loose the lug. The sign convention for torque depends on the rotation it causes. Torque is negative when rotation is clockwise and positive for counterclockwise. Both Hermes and the Cyclops sitting on a seesaw where the pivot in the middle act as the axis of rotation. The respective weights generate torques that acting both clockwise and counterclockwise. The seesaw becomes imbalanced as the Cyclops has greater weight. To balance the seesaw, Hermes needs to increase his torque by extending his position relative to the pivot without changing its weight. For a person who weighs about 68 kilograms, he could move massive objects as long as he has a long enough lever to lift them up. This method was originally introduced by Archimedes. In his famous quote says that, "Give me a lever and a place to stand and I will move the earth." Moment of inertia is defined as the resistance of an object to the rotation which initiates by some torque. This property is similar to the inertia that we have learned in Newton's law. In general, the moment of inertia is the sum of individual mass m times its distance from the axis of rotation r squared. For a rigid body, like a tennis racket, it has three axes of rotations which allow rotations in three different orientations. When the racket is turned about the first axis, the distribution of the masses is near to the axis of rotation. The moment of inertia about the first axis is the smallest, and as the result, the racket spins at higher angular speed. On the other hand, rotating about the third axis has the greatest moment of inertia, as masses are distributed further away from the axis of rotation. The racket spins slowly compared to the first axis. Different objects will have different moment of inertia and depends on their shape and which axis the rotation takes place. Often, we saw a skywalker uses a pole. The pole distributes mass away from the pivot point, thereby increasing the moment of inertia and help the walker to keep his balance. Angular momentum is the product of the moment of inertia of the body times its angular velocity. The principle of conservation of angular momentum states that if there is no external torque acting on a system, the total angular momentum of the system remain unchanged or constant. Mathematically, the total of initial angular momentum is equal to the total of final angular momentum for that system. Spins are all about physics conservation of momentum. They are also critical element in scatter's gravity-defying jumps. To do the spin, a skater needs to pull in his or her arms close to the body. The moment of inertia goes down and the angular velocity or speed goes up.